All right, so we are doing inverse relations and functions, and we are going to talk about what a function is, if it's one-to-one, and also how to find the inverse of a function. So, some vocab words. Independent variable, it's either like my domain, my input, an argument, if it's like a word problem or a real life scenario. Dependent variable is my output or my range. A function. Okay, remember, a function is every x goes to exactly one y. No repeating x's. Okay, we learned this back in Algebra 1. A one-to-one, oh, it must pass the vertical line test. Okay, a one-to-one function, one-to-one means that every x has its own number, every y has its own number. Nothing's left out, nothing's missing. So one number goes to one number, one-to-one. Every x goes to y, every y goes to x. Nothing's just hanging out, nothing's repeated, okay? It must pass the vertical line test and the horizontal line tests. An inverse relation is formed when I switch my x and y values, which means that the ordered pairs are switched. And we're going to do that closer to the end of the lesson. First, we're going to talk about, is it one-to-one? One-to-one means every x has a y, every y has an x. Nothing's left out, nothing's missing. A function means that I have no repeating x values. All of my x values are different. Okay, so here we go. Identify the inverse relation. Inverse means that I switch the x and y's right here, right? So here's my inverse function. So I'm going to make a whole new table of values. And x is going to be switched in. I need 1, 2, 3, 4, 5, 6 spaces. 1, 2, 3, 4, 5, 6. So instead of -1, 9, I'm going to put 9, -1. 7, 0. 5, 1. 3, 2. 1, 3. -1, 4. So all I did was and I can even go, yeah, that's better. I'll even go bigger. Okay, so remember, oh wait, I don't want to block it. Anyways, you're switching the x and y values. But if I switch the x and the y values, is it still a function? So I'm going to write that. If I switch the x and y values, is it still a function? So now I'm going to look. Let's look at the original that I got. Are all of my x's different? -1, 0, 1, 2, 3, 4. Are all of my x's different? Volunteer. I need to see like your hand and your name. So like digitally volunteer or whatever. Raise your hand. Yeah. Kelsey.
Yeah, the x's are different.
Yes, the x's are different. Good. Now, is the inverse a function? 9, 7, 5, 3, 1, -1. Is that a function? All I care about is the x values when I look at functions. Are there any repeats? 9, 7, 5, 3, 1, -1. I'll answer, it's a function because all of the x's are different. So the original is a function and the inverse is a function. Okay, now let's go here. Number 1, is it a function? And then we're going to talk about one-to-one. So I need help. This is going to take forever if nobody volunteers. And I don't want to hear from the same people. You know that. If you already volunteered this week, I don't want to hear from you. Number 1, is it a function? Nathan?
No.
Because, well, you're only looking at the x values when it's a function. Are the x values different?
Yes,
No.
they are.
They are different. So that means
Oh,
yes, it's a function. You're thinking of the one-to-one question maybe. Is it one-to-one? Does every number does every number go to another number? What about this C? What's going on there? This is not good. It is not one-to-one. I can't have just a C hanging out by itself. How? No. Okay. Number 2, is it a function? Are the x's different? Logan.
Yes.
Yes, it's a function. And is it one-to-one? Does every x go to a y? Aaron.
Yeah, it's 1-to-1.
Yes. Good. Love it. Okay, we're gonna do the same thing on the next page. Practice. Is it a function? Is it one-to-one? So number 3, look at my x values. Is it a function? Yay or nay? Josh,
It is not a function
because?
because 2 x values are assigned to one y value.
Oh, okay, that's okay. That means it's not one-to-one. But
It's
what
the
I care
opposite,
about,
right? So that would mean 1x to 2 y's.
right,
would be
x's are all different. If the 4 was trying to split itself and also go to b, that would be not a function. But the way it looks right now, it's yes, a function, but it's not one-to-one. It's not recording. Oh, it is. Sorry. That's going to be in my video, me panicking. Okay, number 4. Somebody, is it a function? Yay or nay? Andrea.
Yay.
Oh, Andrea first because she raised her hand. I'll go with her.
Yes, it's a function.
Good. Perfect. The gentleman that just spoke, is it one-to-one?
No, it is not one.
No.
No. Because that 4 is just, I don't even know, doing whatever the 4 does. It's not good. Okay. All right, last one. Do it by yourself. I'll give you like 30 seconds. I'll press pause while because we don't want, just nothing on this video. Volunteer, please. Is it a function, yes or no?
Yes.
Oh, it's not. Because nothing's happening with the 1. The 1's not going anywhere. It doesn't have an assigned y value. So sadly, not a function. Which also means that because 1 is going nowhere, A has no attachment, B has no attachment, it is not one-to-one. Okay? All right. So here we go. Now we're going down and we're looking and seeing which one of these is a function. Find the domain and range. Okay? So I'm going to do just scanning. You want the x's to be different. Number 1, it's not a function. Number 2, yes, it's a function. Is every y value assigned to an x value? So yes, it's one-to-one. You have to list the domain and you have to list the range. So that means all of the x values need to be listed after the domain. That's going to be 1, 2, 3, 4, 5. The range is going to be the y values, right? You just list the y values. 1, 2, 5, 10, 15. Good. Okay. Number 3. Are the x values different? -1, 0, 2, 3. Yes, they are. The 1-to-1. Are all the y values assigned to a different? Oh, look at, guys, look at that 3 repeats. Not 1-to-1. Next thing to do is list the domain and range. Five, 3, -1. I did not list 3 twice. I didn't need to. Okay. All right, recall all the parent functions you've learned. Which ones are 1-to-1? 1-to-1 means that it passes the vertical line test and the horizontal line test. That's 1-to-1, okay? So what I'm gonna do is I'm gonna give you 4 examples of parent functions that you've learned. So basically you're just gonna be copying, okay? Because I'm just going to draw the pictures for you quick. I'm gonna use different colors. I have a red and a green to be able to go through this. And here we go. Are you guys okay? Does anybody have any questions? I'm gonna check in with you. Okay. Guess that's a no. All right, you guys. 2 to the x power. Exponential function. Ready? Make my coordinate plane arrows at each end. Here is what it looks like when you draw it. Do, 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 do. Okay. This is 1-to-1. It passes the vertical line test and it passes the horizontal line test. Next, y equals the absolute value of x. That's the V-shaped, remember? This doesn't pass one of the line tests. Which one does it not pass?
The Y one?
Vertical or horizontal?
Or there's a two X values have the same Y value. So is that horizontal?
It's a horizontal line test. It'd be like this. And I'm going to say that there's repeating Y values, not 1-to-1. Okay. All right. Third one that we've learned. A basic parabola, quadratic, your generic normal parabola. Okay. This, sad news, does not pass the horizontal line test. Not 1-to-1. It's like the same thing as the last one. Lastly, the last one that we've learned was the most recent that we graphed with horizontal and vertical asymptotes. Do you guys remember that? Of course, it looks all perfect. All right, ready? And I'll do it like, I'm making it perfect for you guys. Here is my vertical asymptote. Here's my horizontal asymptote. That does pass both the horizontal line test and the vertical line test. It's 1-to-1.
Do polynomial functions count? Like,
Yeah. Well, that's these, right? Like you're saying if you had like a trinomial at the bottom.
no,
That
the
would
ones where
fit.
it's like it goes up, or it goes from down to squiggle and then up.
Well, like this? Like that? Because those do not pass the horizontal line test.
Oh yeah.
That'd be like to the third power, to the fourth power, to the fifth power. Okay. Moving right along, friends. Where are we on time? We're good. We're good. Okay. We're going to talk about inverses now. Inverse means the ordered pairs are switched. Inverse means the ordered pairs are switched. So, okay. A function must be 1-to-1 in order to have an inverse function. 1-to-1 means that it passes the horizontal line test and the vertical line test. Remember that? The graphs of inverse functions have a symmetry in line y equals x. Let me draw the line of symmetry for you. Okay, ready? Y equals x. Okay. So, two functions, f and g, are inverses of each other if and only if f of g of x equals something and g of f of x equals something. If they equal the same thing. We didn't talk about this yesterday, them ever having the same answer. When I do f of g of x and g of f of x, yesterday none of them were the same result. Okay? So now what I'm going to do is I'm going to go down and I'm going to do example 1 and I'm going to graph it. Remember, an inverse means that the ordered pairs are switched. So here's the steps. First, you have to graph the function that you're given. Step 1, graph. Step 2, switch x and y. These are the ordered pairs, guys. And then you graph your new, and that's going to be the inverse. So that's what I'm going to do right now. I'm going to graph y equals 5x minus 4. And I'm going to draw that in pencil, okay? Y equals 5x minus 4. You can go ahead and graph it as well on your own. Let me turn this on like that. That's nice. Negative 4. 1, 2, 3, 4, 5 over 1. Begin at negative 4. That's my y-intercept. Rise 5, run 1. 1, 2, 3, 4, 5. Run 1. Okay. Oh no. Here we go. Connect the dots. La 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 la. Okay. I'm going to make note of what my ordered pairs are. 0, negative 4, right? That's my y-intercept. 1, 1. That's good. 2, 6. Now, my inverse, I'm going to make in green. And I first have to switch the x and the y ordered pairs. Negative 4, 0. 1, 1. 6, 2. I just rewrote them and I switched them. So you're switching the x and the y graphically. We're also going to do it in an equation where you just literally switch the x and the y. That comes next. My green line will look like this, this, this. Okay. Connect the dots. Hold on. So now, I want to show you what inverse looks like. Please keep your eyes on the red line. Notice how my pencil and my green line are basically reflected over that red line. The pencil and the green line are reflected. Doom, doom. See that? That's always going to be how inverses look. So you'll know you're on the right track if when you look at the y equals x line, if you've got some sort of a pattern going. Just in case you were wondering, the equation for the inverse is 1/5 x plus 4/5. And you're probably wondering, how did she know that? I'll tell you. I knew that because I switched the x and the y values and solved for y. And I'm going to model that in the next problem. There. So we're going to be asked not to graph this time, just looking at it. Are f of x equals x cubed minus 5 and g of x equals the cube root of x plus 5 inverses of each other? Here's how you find inverses of each other. 1, switch x and y. Step 2, solve for y. Y equals x cubed minus 5. Okay. And switch x and y. Watch this. Instead of x, put the y. Instead of y, put the x. See what I did there? Now I'm going to add 5 to both sides. X plus 5 equals y cubed. Step 2, solve for y. Any idea? Someone help me. I need help now. How am I going to get y alone? What am I going to do? Who's Zepha?
Take the cube root of y cubed.
I am. Cube root of both sides. Ready? The cube root of x plus 5 equals y. Is that the same as this? Are they inverses of each other? Yay! They are. Yes, they're inverses of each other. So we're going to practice that 2 more times. Switch x and y and solve for y. That's on the next page. And we're still doing so good on time. We're not going to do this down here. Don't even worry about it. Okay. Switch x and y. First, write it normally with a y. 1/2 x plus 3. And I need help the whole way through on this one because there's only 2 problems left in notes and then you're done. So help me out. switch X and Y, and then solve for Y. Someone, please. Thank you, Sarah.
Would it be x equals 1/2 y plus 3?
Yeah, perfect. Do you want to solve it or are you done helping?
I can solve it, I guess.
Awesome. Do it for me, please.
So you would subtract 3 to get x minus 3 equals 1/2 y.
Uh-huh.
And then you would probably multiply, or like you would divide 1/2 to each side. But yeah,
No, multiply was the right word. Multiply what? By both sides.
you would multiply 2 to each side.
Yeah, the reciprocal. You were right the first time. Trust your first instinct. So 2x minus 6 equals y. That's my inverse. Okay. Number 2. Volunteer. No? Thank you, Mary.
First start by switching the x and y, so it becomes x equals y cubed minus 1.
Good job. Okay.
Do you want me to do the rest? Or?
I would love that if you want to.
And then you add 1 to both sides.
Uh-huh. X plus 1 equals y cubed. Okay.
And then I don't know how to say it. You like you square root it, but with the cube. I forgot what it's.
Yeah.
I forgot what it's.
You said it. Cube. You cube root.
Cube root.
Instead of
Yeah.
square root, you say cube root. I cube root both sides. It is tricky, I know. So the cubed root of x plus 1 equals y. And that is the answer. Okay. So good. Okay, your homework is just practice on exactly these type of problems. So you are good, you guys. Let me stop recording. The homework is attached in Google Classroom.